What is given? Harmonic oscillator of potential V equal to half m omega square x square. Uh, we are having a rising and lowering operator A and A dagger with this expression. Find bracket notation of n x k where n equal to 0, 1, 2, 3, etc. So for this, to find this expression, we can use raising and lowering operator. So this is the expression for A and A dagger. So we want x. So to get x, we have to add A and A dagger. Adding A and A dagger, we get 2 into root of m omega by 2 h cross x, which gives x equal to root of h cross by 2 m omega A plus A dagger. And if you want P to find NPK, we have to subtract A and A dagger. If we subtract these two equations, both the x term get cancelled. You will be getting 2I by m omega. So P will be equal to m omega by 2I, A minus A dagger. Using this operator expression, we can find this value. How to find this value? So substituting this A plus A dagger, taking the constant outside and separating A and A dagger separately. Writing A and A dagger separate terms. We know that A operator operating on n will be giving root of n minus 1. As A is a lowering operator, it acts on n and it will be giving n minus 1. Rising operator A dagger when operating on n will be giving n plus 1 vector with eigenvalue root of n plus 1. So only we are calling this as the lowering operator and A dagger as a rising operator. Substituting this one, A operating on k will be giving root of k into k minus 1. A dagger operating on k will be giving root of k plus 1 into k plus 1. Using orthonormal condition, you can take the root of k outside, you will be getting n into k minus 1. So this bracket notation will be 1 only when n equal to k minus 1. And here this bracket notation will be 1 when n equal to k plus 1. So n equal to k minus 1 and n equal to k plus 1. So when n equal to k, that is when n equal to 0, k equal to 0, this value will become 0. So the diagonal elements will be 0. So let me see this. So this is the matrix we are going to form with n as a row and k as a column elements. So n equal to 0, k equal to 0 is the first element which will be 0. N equal to 1 and k equal to 1 will be the second diagonal element. That also will be 0. Similarly, all other diagonal elements will be 0. Let me evaluate other elements. So when n equal to k minus 1, n equal to k minus 1, we will be having the first term and the value will be root of k. So when n equal to k minus 1, eigenvalue will be root of k. So when n equal to 0 and k equal to 1, these two will be 0. When n equal to 1, k equal to 2, these two will be 0, equal. Then n equal to 2 and k equal to 3, these two will be 0. So the eigenvalue will be n1 root of 1. Because n equal to 0, k equal to 1. K equal to 1, eigenvalue will be root of k. You will be getting root of 1. Here k equal to 2, eigenvalue will be 2. For n equal to 2 and k equal to 3, this will be equal and the eigenvalue will be 3. So what is this n equal to 0, k equal to 1? This is the element n equal to 0, k equal to 1. So you are substituting the eigenvalue root of 1. Similarly, n equal to 1, k equal to 2, substitute the eigenvalue root of 2. Here root of 3. Other elements will be 0. Similarly, we are having second term. Second term will be having value when n equal to k plus 1. The value will be root of 1. So n equal to k plus 1. If n is 1 and k equal to 0, these two will be equal. N equal to 1, k equal to 0, these two will be equal. The eigenvalue will be root of k plus 1. So root of k plus 1 will be root 1. Similarly for 2, n equal to 2, k equal to 1, root of 2. N equal to 3, k equal to 2, root of 3. Substituting this value, n equal to 1, k equal to 0 is this element, matrix element, root of 1, 2, 3 or substitute, all other elements will be 0. So this is the answer for n, x, k. Similarly, you can find the value for n, p, n, p, k.